So this is the AI in design verification session. My name is Mark Smolinski. I'm a professor at the University of Southampton in the UK. We have 3 talks this afternoon, but 4 speakers because the last one has 2 speakers. The first speaker is Marmit Soni, who's from Tessolve, as you can see on the screen. He's technical manager at Tessolve, leading AI and ML innovations in design verification and functional safety. With over 15 years of experience, he has developed 25 plus AI tools driving efficiency across semiconductor workflows. A recognized speaker and strategist, he actively contributes to industry conferences and research. Mike, over to you.
Hi, good afternoon, everyone. So myself, Marmit Soni. I work at Tessolve, and I work there at Center of Excellence. So we are working on different tools these days, which are utilizing the power of AI, and we are making the life easier for the engineering teams, different teams. So those teams are including the verification team as well as embedded team, or across organization, whichever team is having the repetitive tasks, data intensive tasks. Over there, we create the solutions for them. So here I'm today going to talk about the 3 tools. Those are showing the different directions of usefulness of AI on the design verification part. So the title of the topic today is Efficiency Improvement and Automation in Design Verification using AI. I have been working with Mike when we have started all this work. I have to go to Yeah, so first of all, a very 30 seconds of introduction of Tessolve. Tessolve is the end-to-end solution providing company where we are having the spread across the globe with some 11 countries, and we have some 3,500 around engineers. And we are almost working with 75% of the top 25 company in the world. And we have complete chip design, verification, testing solution, everything from the spec to the final end product. We have it all being supported by Tessolve. So today's presentation, we have the variety of tools available. We have designed those tools, but I'll be talking very quickly about the 3 key tools. Those are showing the potential of AI. The first one is UVM AI training tool. So the straightforward use case of generative AI is in the training part. So that is helping people on their queries. So that is one of the tools there we are using the AI. And the second one is a certified tool. And the third one is the spec extraction tool. So there we do the design verification activities. We try to leverage the efficiency and the time cycle with the help of AI. So that's the third tool. So how we do this all? So this is a recipe for us. So we have the combination of all the key things. When it comes to generative AI, we are knowing that it will be about models, right? Every new week we are listening about some new models, some development, and those are having certain benchmarking, and some of them are good at content generation. Some of them are good at writing the code conversions. So we do play with different models. We do use AI for context, and we do the context training, and then we utilize the capabilities of AI. We also now, as we know, that it's not about just generating the content with the help of models related to your project or PDFs or specifications. It is more about now going towards the agentic approach, where the agents are taking the actions for you. Those are getting integrated with the tools. So so there we do tool interface with our AI tools. So agents for that we are calling, and those are taking the actions by the interface with the tool. The next part is the data passing and generation. So wherever we are having the data available in the systematic format, machine readable format, be it the specification or with the verification plan or anything. So there we do a lot of data passing and generation, guiding people on their queries. So there we use a different approach. Some of the solutions are requiring the local implementation, on-prem solutions we are using sometimes, or our contained PDF data, and sometimes we also use the, according to the application, we use the web over there. So the key thing is also about, apart from generating the content, we also do the code conversion. So when it comes to, for example, the RISC-V migration, so over there also from the legacy codes or drivers, we convert with the help of AI to the for the RISC-V migration. So how we, this is our strategy. I'll be quickly taking you through that. So we have the training data. We use it with the help of the latest model, which we are benchmarking, which we are using. We are testing it extensively, and then we finalize, okay, we'll be going with this. Then in one of the, this is kind of one of the basic architecture which we are using. So we do use the prompts. So there are prompt engineers in our team who are knowing how to get the information about in a better manner. So we use prompts over there. We record those prompts, and with the help of that, whatever results are there. So we, in some of the cases, we have right now some 25 variety of tools available. So I'm just giving you the quick overview of that. So we try to do the automated testing of the generated content. For example, we are using somewhere open source tools which are integrated with the generated content, and there we are getting the results simulation. We are getting the errors even reported in the test benches. Those things we do. And as we move forward, we have new models are getting available. So we have now established a system where we try the new model, which is getting trained on our historically available data, and then we plug and play. If we find it appropriate, then we plug and play that new model instead of our model one. So this is our strategy, how we generally work. Okay, different solutions may be requiring some additional components or something from this or something getting removed from this, but this is the basic architecture with which we work. So obviously, when it comes to AI, we know the security is the concern over there. So we are, according to the requirement, suppose it is basic training, then we don't care much about those things. And we use the cloud services over there. In some of the cases where we have the data which is quite client-centric data, client projects are there. So there we use the on-premise solutions also we build. So on-premise, clouds, and the other stuff that we do, model repression, model selection, prompt group is there. What we design, different kind of bots, access control, all these mechanisms we use normally. So this is the flow. I'm not going much in the detail for design verification. All of us are mostly knowing this flow. But what processes are involved and what are the entities involved in those processes, and what are the inputs for each of the entities, and what impact it creates on the output. So those I have tried showing here. So here at this point, spec to the verification plan and few of the other things I'll be showing you where we are using the AI. So here we are trying to generate the UVM test benches with the help of automation. Here we are using generative AI models. So this is how we have divided the flow in two of the categories. Somewhere automation works better. Somewhere we are using the AI engines. So now we are talking about three tools which I showed you initially, which I have listed initially. So this is for the training. I'll be showing you very quickly what features we have in this tool. So we are using this for the organized content. We have training material, then organized content we are putting over there, so people can go through one by one the topic and they can complete the journey of learning, their learning. We have the very important topics listed as quick topics, MCQs. So AI is conducting the test over there for the people, and whatever answers people are giving for the topic, AI will be evaluating, giving the marks, it will be recording the results, and it will be suggesting, here you have made mistakes, so you should go through this topic. So this is for mostly useful for the beginners, initial engineers. This will be quite effective. Then FAQs are the Q&A, as I mentioned, and we have the dashboard also for monitoring the performance. So this is kind of typical application where directly AI is quite useful and quite popular just on the training part. So this is how it looks like. All the features which I mentioned over here, generating MCQs, top 10 FAQs, Q&A chat. So it becomes like Chat GPT for Tessolve verification. Okay, so that's not that is not using the Chat GPT model, but it is trained on the on our own training data. Yeah. So the second tool, let me talk about the second tool, which I have named it as Assertify. It is useful for generating the assertions. This is just one use case which I want to take over here. Just within the time frame we can finish. That's why. So what are the problems typically? So growing complexity, human errors, the time intensive asks are there, lack of consistency and skill gaps are there, right? So how we can take help of AI for this? So the use cases, the generating the assertions from the spec and engineer simple description. It can be the portion of the spec which the engineer is feeding to the tool, and generate the description from the SVA code. So two of the aspects are there: generating the uh, SVA as well as describing the SVA. So two of the aspects are there. So the first aspect, description, and it is using the design signal. So we are feeding the top level signal, top file over here, and using that with the help of AI engine, it is generating the SVA code. So it is not just generating the SVA code; it is generating the SVA code with the signal names which you have used in your top file. The second part, SVA code, AI is trying to explain that. Every time over here, it is mentioning that in your spec you have mentioned CLOCK. Obviously, in spec mostly it will be written as CLOCK maybe. So in the top file it is mentioned as CLK1. So I have tried taking CLK instead of CLOCK. So that's how it is explaining everything. So you know what you are accepting, you are rejecting or accepting. You know exactly what the engine has tried creating. That makes the job easier. How it looks like. So very simple example I'm giving you. So here you can see English to SVA, SVA to English, means natural language. So here you are putting just simple description of some example, some text you have taken from the spec. Here you are uploading your top file, and using that it will be trying to create the SVA. It will be also explaining what it has done. So here you can see AXI underscore top.pdf. This is the top file that we have uploaded. This is the description from the spec, and using it, it is giving you the SVA code as well as the mapping detail. So this is how we are making it easier and systematic. Every time, maybe it can give you the same kind of consistency in the answers if you are using this tool. So that's the intention over here. Similarly, natural SVA to English, so it will be trying to explain that very easily. So for those who are trying to suppose learn SVA, for example, so there it will be making it easier for them to understand. So here we have taken different use cases. As I mentioned, in the top file, it was mentioned like this, for example, case mismatch. We have done the study we are doing the research for each and every aspect. This is just one example. So here case mismatch is there. In top file, it is mentioned as AXI underscore AW valid, suppose the signal. In the English description, someone has taken from the spec and they have taken it like this. So in the signal which is generated by the tool, the SVA which is generated by the tool, it is taking the correct name. So these are different use cases. Partial mismatch is there. There also it is taking care. We want this, right? In top file, it is mentioned like this. So we want it like that, right? So it is taking care of, even you can see the extreme example. AXI underscore AW valid is mentioned in the top signal. And here it is mentioned as VLD in your description, probably, right? Still, it is understanding that, yeah, we are talking about the valid signal. So these are just experiments to make sure that we are delivering the quality tool. This is a demo that we can just skip, right? Because we'll be having limited time. So yeah, what are the benefits? Enhanced efficiency, reduce human error, quick AI adaptation, how to incorporate AI in our workflows very efficiently, quickly, making the experiments. So there it is very helpful. So the process is getting streamlined over here. We are providing a systematic tool, systematic approach for generating the assertions. Obviously, when it comes to AI, I have kept it very simple. The problem that we all know right now, sometimes it may make mistake. But obviously, you guys know that before 1 year, what issues we were facing with the models. Right now, the latest models are much more capable. And if we compare it with some fresh engineer, maybe the quality is sometimes mostly better as compared to the beginner, right? And again, right now, all the tools that we are having, it's not completely, now we are not having it connected with the tool ecosystem, with the EDA tools. So there still the manual validation takes place in many of the tools. That is one of the conventional, right now, the problem that we are facing. The third tool, that is the DV Spec Extraction Tool. So this is the third use case, a little complex, where it is expected to reform the way we look at the verification. So we are having different racks, dynamic rack, conventional rack, agentic rack. So all these racks we are using for training the tool, which is generating the verification plan for us, is writing the constraints, it is creating all the components of a typical verification plan. Okay, feature extraction, what is the related register values. So all these things we are doing with the help of this tool. Yeah, thank you. Yeah, so this is the RAG architecture, just one of the RAG architecture that we are using. So this portion that you are seeing over here is fixed data chunking, additional training data that we want to give for a specific domain. So that is fixed. Index data, that is also fixed. Lookup prompts. Prompts means base prompt. How you want your system to be behaving. That we call kind of base prompts. So when we are migrating from one project to another project, the spec will be different, the top file will be different, but after that the system remains same and the user does the query. Okay, right now we are predefining some 20, 30 operations from the prompt experience that we have seen over the period with the same tool. So we know that, okay, list out important features for me, right? This will be the common question people will be asking. So now we are creating the tool where this kind of prompts are in the form of buttons over there. We click it, we are getting the list, we are able to download, we are able to copy the content from there. So it is using this again LLM. So it is better in a better way. It is trying to understand the content that you have provided. And that's output. So there are different models for different applications, as we all know. We use these models. So where it helps: feature extraction, test case generation, constraint generation, cover point generation, assertions, and DV plans, spec to test. So DV plan also it can help. So spec model benchmarking we do, which model is performing better for my use case for this particular specification, prompt and response recording, filtering by manual validation, and then we are putting confidence score, two confidence score, one with the help of AI. AI tells me that I'm 0.9 is my confidence score, 1 is best, 0 is worst. So it will be telling us how confident I am from this while generating this content. At the same time, when we are doing manual validation at this point, we are asking our engineering team, tell me how happy you are with the answer, how much relevant it is, right? So that's how we work. So yeah, this is how it looks like. We have the demo, but the video is that I'll be skipping, but I'll be quickly showing. So simple examples like description for different bus channels in the given AXI4 specification. So it will be giving us the list for that. It will be giving us the idea that how confident it is and what is the relevancy score at the bottom. So that's how the tools are defined. You can see URL we can upload, PDF we can upload. Obviously PDF we need because that's the spec we have, right? So base prompt, and this also looks like. So quick overview on how the tools are looking like. One more example, a feature description for AXI4. So it will be giving you the detailed idea about it. So we do the assessment also, RAG assessment on how the tool is behaving. Is it giving us the quality response or not? Let me just skip this part. This is the RAG assessment. The important thing over here, as we know, we are moving towards a future where AI will be everywhere getting mentioned, right? So we want to make sure that we collaboratively work over here. I'm not here to show my tools that, okay, these are the tools and these are wonderful tools. We are open for collaboration, right? So we can work together for the DV flow wherever you are having the ideas or you want to test our tools. We can collaborate together. We can do some research on that and how we can improve. We can get your feedback on that. So these are all the domains. If you know some of these things, we'll be happy to collaborate. So AI aspect, we are doing a lot of research on that part also. So if you are probably as you are over here, if you know AI and you are much interested in that direction, then also we can collaborate and work together, right? So that's it from my side. You can connect with me, Marmik Soni, on LinkedIn or through this mail. And thank you very much for your time. We have some 20 seconds.
I think, thank you. I think, in fairness, we're running a couple of minutes behind schedule. I think maybe if we take questions offline, and we'll try and make up a bit of time.
Sure.
So, thank you for that. Right.